So, hello guys, welcome to my YouTube channel Veda Stories. In the previous lecture, we have started a series called Machine Learning. So, we have covered a lot of things in it. So, if you haven't watched the previous lecture, I will suggest you to go and watch it, as the notes I am providing in it are the most important notes that it will be helpful for you in the interview. So, in the last lecture, we have started linear regression and we have covered most of the part like what is meant by linear regression, what are the evaluation parameters, and how they work. So in this video, we are going to cover the practical part of it. So let's proceed. So open your Jupyter notebook. I will create a new folder here. I will click on folder. Okay. I will rename the folder as, click on rename. I will rename the folder as machine learning batch. I will click on rename. Okay. So, okay. I will click on it. So before starting the practical, we have to upload a data set that we are going to use to build a model. So I will click on upload, show all files. I will provide the data set in the description of this video. So from there you may go and download it. Click on it, click on open. Okay. I will rename it for my convenience as learn.csv. I will click on upload. Okay. So just note the name as we have to correctly type the name in the Jupyter notebook to load this file. So I will click on new Python 3. Okay. So wait for a minute. It is getting open. So in the last video, I have covered like 6 steps in model building, like understanding the problem statement, load the data, get the data, and data cleaning. These 3 steps are the common step in every supervised learning model. And the next 3 steps, we are going to see it right now. That is sampling, model building, and testing the evaluation parameter. So it is get open. I will rename. Okay. The first step is like importing the necessary libraries. Import numpy as np. Import pandas as pd. I will click on run. Okay. So I have to read the data set, right? So I have to create one variable. I will create a variable a. I will use pandas pd.read csv is the function. So what was my data set name that I have saved here? It is lung.csv. So I will use the same here, lung.csv. I will rename this Jupyter notebook as linear regression. Okay, I will click on rename. Okay, so it looks like lung.csv. I'll use the same here. I will click on run. It's taking time to run, but wait for a minute. It will get run and we will see the data here. And from that, we will derive our problem statement, what to use and which is our target variable and all. Okay, so it get run. So I will use the head function to see the top 5 rows. So as you can see that we have lung capacity, age, height, smoke, gender, and case rate. Okay, so a problem statement is that we have to predict the lung capacity of a person. So lung capacity column is our target variable and all other columns like age, height, smoke, gender, catering From that, we are deriving what is the lung capacity of a person. Okay, so these are like X column, all this column from age, X column, and lung capacity alone is a Y column. Y column is target variable. Okay, so next step we will see the shape of the data, like how many rows and columns are there. So as you can see that we have 725 rows and six columns. So next step we will see what kind of a.info, a.info. Okay, as you can see that we have three object data type here. So while building a model, we don't need any object data type. So we have to convert this object into integer or float. Okay, I will write down the steps here. Firstly, like was understand the problem statement, understand the problem statement, and the second step was okay. The second step was here we have load the data, right? So I will write down here load or get the data. Okay, so now we are doing data pre-processing and data cleaning. Okay, on this step, data, third step is data pre-processing and data cleaning. Okay, so this is the third step. Okay, now we have seen there are three object column. We have to convert it into integer or float for building any model. So now we will see the null values if there are any null values present. If there are any null values present, we have to replace it with mean or mode. Okay. For categorical, if there are any categorical null values, we convert it by using mode, and if there are any numeric null values, we convert it by using mean or median. Okay. So there are no null values here, so we don't need to convert any. So the next step is we have to convert this checked into integer or float. So let's convert it. So we can do it by using two methods. By using replace function, you have to convert it. Like we have to see it. What are the values in smoke, and then you have to manually type like what kind of value do you want for like for example gender have male or female. Like for male you want one, and for female you want zero. You have to manually type it. If you don't want to do such thing, you can use label encoder. It automatically gives value to it randomly, and it convert all the columns into integer or float. So that's the advantage of label encoder. So we will use label encoder here from sklearn dot pre-processing import label encoder. Okay, I will store it in a variable called label equal to label encoder. Okay, so a dot select a dot select d types include all the object column object dot columns. Okay, same I will copy. I will suggest you to don't copy, write it by yourself as it will give you practice. Okay, dot apply. What I have to apply? Lead dot fit transform. Hope it will get run. So we will see it is getting run or not. Okay, so we will wait. Okay, So we will wait. Okay, it is getting successfully run. So all the columns here are converted into an integer or a float. So we will check it a dot head. I will click on run. Okay. So as you can see here that all the columns are converted into integer or a float. So the next step is like sampling. Okay. Sampling. Sampling. Okay. So sampling. In sampling, we divide our data into train or test, right? So the same we are going to perform here. So from sklearn dot pre-processing sklearn dot model selection import train test split. Okay, so a train comma a test equal to train test split. I will use it here. Okay, a comma all the data set I will use it, and test size I will give as zero point 0.2. As in industry standard, 20% is in the test and 80% is in the train data. Okay, I will click on run. I will wait for some time. It is getting successfully run. Okay, so I will create another variable called a train x equal to a train dot ilog. Okay, now we have done the sampling, right? So we have okay, a train x. What I have explained you earlier that these are all the x variable. So we have to give the information to the data that these are the x variables. Okay. So in a train x, we give x variables. So we write here, okay, we don't want this lung capacity column and rest we want. So first we want all the rows, right? All the rows. Okay. We don't want this lung capacity column. So we write here as form one include all the columns. Okay. So in a train y, we use a train dot ilog. Here we want all the columns and the target variable, right? The target variable is 0. Okay. So the same we perform on test. So I will copy it and I will paste it here. And here I will give test, 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 test. I will rename it as test. Okay. I will run it. Okay. So we have done the sampling. We have divided our data into train and test. Okay. So the next step is model building. Model building, right? Okay. From scalar dot linear model import linear regression. Okay. So I will store it in a variable linear regression. Okay, so lead dot fit a train x comma a train y. So here, why we are using this fit function? Okay, so we are using this fit function. So we are using this fit function to train our model, right? So we are giving here two values, that is a train x and a train y. So if you don't run this fit function, your model will not get trained. So what was the next step? We have to evaluation parameter. We have to see. Okay. So evaluation is done only on test data. Okay. What was the evaluation parameter we have seen? The first was like R square, right? So we will see how it is performing on R square. So R square equal to B dot score. Here we have to give you a test data, right? So test and a test Y. So I will run it and I will see the R square. So it is performing very well, that we are getting 85% accuracy. Okay. So the next evaluation parameter was adjusted R score, right? So we will see what value we get in adjusted R square. Adjusted R square. Okay. So an equal to, we have to first select the rows and column, because in adjusted R score we have two values like rows and columns. So we have to first divide our data into rows and columns. Okay. So a test x dot shape k equal to a test. Okay. Dot shape, we have to consider column. Now adjusted R square, we have to perform what was the formula that I have taught you was 1 minus R square into n minus 1 divided by n minus k minus 1. Okay. And here we will see what value we are getting. Okay. We are getting like 85.06% accuracy. It is pretty good because higher the R square, better is the model, and higher the adjusted R square, better is your model. Okay. So the next evaluation parameter we are going to see is MSC. So what was the trend of MSC? Like what we are going to say, lower the MSC, better is your model. So we will check np dot mean, np dot mean. Okay. So np dot mean square error. Okay. np dot square mean. First I have taken the mean, then square, and then error. Oh, we have not defined error. So first we have to define it. Okay. So firstly we have to define error. So error equal to actual minus predicted, right? So actual, we have not defined, just a second, we have to define the prediction here. Pred equal to b dot predict a test x. Now we will see the prediction, what overall prediction it is giving. Okay. So now we have to do the error. What kind of error in it? Actual minus predicted, right? Actual minus predicted and error. We will wait for some time. It is getting run. Okay, just to wait for some time. What it is saying, unable to post to series and must be given 155. Sure. Oh, my bad. Sure, minus predicted. Okay. Now we are getting the error, right? Okay. So we want to find MSC. So we paste it here, mean square error, mean square error. Now we will check. So lower. So it is, as you can see, that lower the MSC, better is the model. Okay. So now RMSC is mean square error. So np dot sq, it is the function. We will check error. RMSC. Just a second. Oh, RMSC root mean square error. Square error. Now it should run. Okay. Lower the root mean square error, better use a model. Okay. So we have performed all the evaluation parameter, and by seeing the evaluation parameter, we can conclude that our model is doing pretty well. Okay. So this prediction is the real prediction we are seeing, like what kind of values it will give when we predict something. Okay. And this prediction, okay, and this prediction we check by using the evaluation parameter, like how it is performing, like like 85% it will accurately predict that lung capacity of a person. Correctly it will predict. So that's all in this video. In this video, we have seen the practical part of linear regression. If you like my video, please subscribe to it, as it will give me the motivation to bring more such video. So thank you for my watching this video, and I will see you next time.